This is going to identify how the breath is delivered to the patient. So we have to have some ways to tell the ventilator, because you have to just remember it's a machine and a computer. So we have to put parameters on it to tell it how to deliver the breath, when to give one, how much to give, and when to end it. And so that's what we're going to talk about today. The first part of it is a lot, because I go into some things that are very important about how your breath is delivered. So know that as we do this first phase of it, the last two are very simple compared to it. I spend a lot of time on the first one. So from your homework, does anyone know what is the name of what for breath? What starts the breath? What's the phase called? Trigger. Yep. So the trigger. So our breath can be either time triggered or patient triggered. So we're going to talk about time first. So the trigger is time or patient. So literally, the ventilator will deliver breath because it's time to give one, or because the patient has triggered it and the ventilator sensed it and said, oh, the patient wants a breath, I'm going to give them one. So that's when it will start. So let's talk about, I'm actually going to need a couple different colors. I'm going to have to go grab some markers. Okay, so we know by looking at, this is a waveform, and you guys are going to see me draw these as we go forward, so they'll start to look familiar, but you won't really know what the waveform is until later on in the term, but that's okay. So I will tell you that this is the pressure. This marker's going to work. So we know it's a ventilator-delivered breath when it's all positive, okay? So as soon as the breath is delivered, it's going all positive. Because if it was a patient-triggered, what would it do? Go negative. So the patient-triggered breath, you'll see this little dip in it. So we know that these are all time, and where you see the little negative drop, that's a patient. And some of the vents even change, like they'll, like one of the vents has S for spontaneous, T is another thing that you'll see for time triggered. Some of the vents have a little dip on there that'll give you a little down arrow every time something's happening. But at the end of the day, if you just look at the waveform, time, 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 and a patient triggered breath. So how does the vent know when it's time? What do you think would determine that? Well, how do you tell it though? What do you set?
You set the rate?
The what? We're going to get to inspiratory time, but somebody said it, you set the rate. And the rate is going to be what? So the time trigger is determined by the respiratory rate. And what we do is take, it's going to be what we call the total cycle time. And that's abbreviated TCT. And that equals 60 divided by the patient's respiratory rate. 60 seconds in a minute, how many breaths are we delivering? That will give you what we call the total cycle time. So if your, if your respiratory rate is 12, very, very common rate, what would your total cycle time be? It would be 60? Yes, 5 seconds. So if your respiratory rate is 12, your TCT is 5, and that's seconds. So if your respiratory rate is 10, what is your total cycle time? 6. 15, 4. So by changing your rate, you change your total cycle time, and that will change how often a breath is delivered. So what this means is every 5 seconds, the ventilator is going to deliver a breath. So the total cycle time is from here to here to here. So from one breath to the start of the next. So that portion there. And then within that total cycle time, what has to happen? Right, so, Carl, what does that compose of, though?
Inspiratory and expiratory.
Correct, so inspiratory and expiratory. So on this little waveform that I drew, this is inspiratory, this is expiratory. So this is gonna be inspiration. And this is expiration. Inspiration, expiration, inspiration, expiration. So within here, your breath has to be delivered and your patient has to have time to exhale. This is where I time and E time exist. This is going to be your I time, this is going to be your E time. So I time, E time. Inspiratory time, expiratory time. A lot of times it goes by I time. And we'll talk about E time. So normal inspiratory time is 0.8 to 1.2 seconds. 1 is a very good, happy I time.
What did you say was a good eye time?
0.8 to 1.2 seconds, but 1 is a perfect thing to pick. It's very easy to remember. 1. You'll learn as we go forward that some patients that have air trapping would have shorter I times because they need to have a longer E time. And what you're gonna see is that whatever your I time is, the E time is the difference between whatever the total cycle time is and whatever the I time is. So let's say that my I time is 1, my total cycle time is 5 seconds, so what is your E time? 4. Yep. So if I time is 1 second, E time is 4 seconds. This is just an example. So the E time equals your TCT minus your I time. So we do not set expiratory time on a ventilator. It's determined by the respiratory rate, this is one of many things, but the respiratory rate and the I time. Will determine the expiratory time. I don't worry about expiratory time that's too long. I'm worried about expiratory time that's too short. So you know how we'll talk about too next week, we'll talk about compliance. I don't necessarily worry about compliance that's too high, I worry about compliance that's too low. I'm not worried about if my E time is too long, I'm worried about if it's too short. So like if your I time is 1 second and your E time is 1 second, that's not normal.
So E time is usually longer than I time?
Yes, E time is always longer. Average, at a minimum, your E time should be 3 to 4 seconds, just to give you a number. But we would mostly look at whatever our I time is and let our E time be whatever it will be. So, if my I time is 1 and I change my rate to 10, which changes my total cycle time to 6, what did I do to my expiratory time? I made it longer, yes. If I dropped my I time from 1 to 0.8, what did I just do to my expiratory time? I made it longer, right? So, ways, that's not gonna work. Ways to fix air trapping. Also known as auto PEEP or intrinsic PEEP. You'll see it called all these different things. And I'll tell you that this is all over the boards. Fixing air trapping, it's a big topic that they test on. And we're gonna drill it into your heads, and we're gonna talk about it all the time. Because it's very important if your patient is air trapping that you fix that as well. So what did we just learn? One way to do that. Decrease the eye time. So drop your eye time. So decrease the eye time.
Or increase the TCT.
That's not an actual answer because you can't go and turn a knob to increase the TCT. So we'll get there in a minute. Sam?
Would you increase your eat time?
So what you need to know about this is the ultimate solution to fixing air trapping is to increase your E time. But there's no knob on the ventilator that says E time. So it's not the answer because you can't go to the vent and say increase E time. So the solution here is to increase your E time. But you do that by doing these things. So your answer can never be increase the E time. Does that make sense? Because that's not something that you're gonna actually do. Now, if a question comes up that says, what do you have to do to correct air trapping? And one of the answers is make your expiratory time longer, then that's just a concept check and that would be right. But if it's actually making changes, that's not a change you can make, Mitch.
You can lower your rate.
Yeah, we'll get there in a minute. I'm gonna do them in the order. Because rate is one, but it's the bottom one that we do very last, okay? So thank you though. Okay. So we get, if we change I time, we change E time. So what you're seeing here is that all these things play together. If I change my rate, I change my E time. I change my total cycle time. So I time and E time. The other part that comes into play with I time and E time is IE ratio, which is different than a time. So we also have the IE ratio. And you have to think of that like parts of your pie. How many parts of the whole are going to be inspiration and how many parts of the whole are going to be expiration? So we always turn it into a 1 to something ratio. Now if your I time is 1 and your E time is 4, it's a 1 to 4 ratio, but it's not always 1. So the way you figure this out is you take a 1 to whatever, and the answer is going to be your E time divided by your I time. So if this was 4.0 and this was 0.8, I'm trying to make easy math. What is my ratio? 1 to 5. Because 8 goes into 45 times. So that would give us a 1 to 5 ratio. But don't get confused because a lot of people say ratio and they go, my E time is 5 seconds, and it's not. These are pieces of the pie. So one part is dedicated to inspiration and the other 5 are expiration. I time and E time is in seconds. A normal I to E ratio is 1.3 to 1 to 4 or higher. So the normal ratio is 1 to 3 to 1 to 4 or higher. So again, I'm at the point where I don't care if it's too long, I care if it's too short. So if you see a ratio that's 1 to 1, 1 to 2, your patient's not getting enough time to exhale. So what's another way I can fix air trapping? Increase the ratio. And what you'll find is depending on the vent that you're working on, you might be able to change the I time. But you might not be able to, and you have to change the ratio, because every vent is different, that's just the way it is, don't blame me, I didn't make them. But some vents let you change the eye time, some vents change the ratio, and by changing the ratio, you change your eye time. Does that make sense? Because if you make your ratio larger, it would make your eye time smaller. So that's where you have to, and this is why I talk about these now, because they all play together. If you change one, you change the other. So depending on what's on my vent, I could either decrease my eye time or increase my ratio. Everybody with me so far? Yeah? Yeah? Okay. Oh, that means it's time for a break. I forgot to turn my phone off. Okay, it is time for a break. Come back at 9:40, please, and we'll pick up where we left off.